Okay, guys, so we're going to continue here. And yeah, then we'll just stop once again after 35 minutes, all right? So, we talked about why is that we need to verify that we've installed Docker. Okay, so we stop here, right? Open the terminal in your local computer. This should be called terminal. Okay, so we are going to open our command prompt. Uh, let's just run it as an admin. Okay, so I mean for the beginners, right, or for the people who are maybe just thinking about switching careers into IT technology. What is a terminal? Okay, so a terminal is where you send instructions to your computer using text instead of clicks. For example, instead of right clicking your desktop and create a new folder, you can simply send a command into your terminal, and it's like sending text messages to your computer operating system to tell it what to do. Okay, um, so let's see if we have the correct version. So we're going to do Docker version, and it looks like we have the version 27.4.0. Cool. Seeing Docker command not found. Okay, so if you have this issue where you have this alert, right? It's asking you to restart both your terminal and Docker desktop and try running Docker version again. Well, I'm not having issues with it, so I think we can just skip this part. What is it? Up and down. If you can find the bottom part, version. Do you see a version number now? Okay. If you do not see a version, it means that Docker is installed but not configured in your local computer correctly. Try hitting the notification bell and look for any issues that can't be repaired. Okay, so it's asking us to open up the terminal here. And how do we do that? So it looks like there should be. Okay, so here it is, right? We have here the terminal. Okay, so we want to, yes, great. So it looks like that's working. Can also run that command here. Okay, so I think I got confused. We're not gonna use our local CMD. We're just going to use the one from desktop from the actual application. So okay, that's fine. That's fine with me. If you do not see, okay, we do see that, and all right. So if you get stuck, yes. So for whatever reason you get stuck with something is not working. They do have these kind of like place, right, where you can ask questions. You're going to collaborate with other people that are working on the same project, and you can find resources. I've used it on the last two projects I was working on because I got stuck with some things. So here you can kind of like use it as some type of guidance to resolve a specific problem, right? Okay. So if you get stuck, I would recommend using that. If not, you have ChatGPT, you can use Google, whatever. Okay. Keep in mind, if I do get stuck with something, we're going to go over everything. We're going to learn how to, troubleshoot specific issue. How is that I go about, finding resources on the internet. We'll do everything together. I want you guys to get the whole experience. Okay. So here, we'll verify that we've installed something called Docker daemon. Okay, look for the Docker icon, a whale in your system tray, also known as your computer's menu bar. Okay, so this is our system tray, okay, this right here. So do we see that little whale? I do see the little whale. I do see an elephant too, but this is something else. Oh my god, they have animals now for icons. How funny. So yeah, so it looks like we do have it. Okay, so it is installed. So the Docker daemon is installed. But why is it gray? So I just right click that, and I mean, as long as it shows there, I guess it's good, right? Um, we'll figure it out. So what is the Docker daemon? Okay, so it says it's the engine that actually does the thing. When you run Docker commands, for example, creating a container, right? In more technical terms, the Docker daemon is a background process that manages the Docker containers in your computer. It takes commands from the Docker client, right? So commands that you type into the terminal, or clicks that you do through the Docker desktop application, right? And it does heavy lifting of building, running, and distributing your containers. Okay, so something I haven't told you guys, right? I've studied a little bit surface level of what Docker is and other technologies. I think it's a great starting point just looking up a simple concept of what something is, right? So from my understanding, right, this is I would like to say like think of it as like the heart of Docker, right? So think about, for example, your body. And I'm making analogies that I'm just creating, okay? So think about Docker as if it was your whole body and the Docker daemon as your heart, right? So what the Docker daemon is going to do is the essential tool that you're going to need for everything to work, right? Because it says right here, it's a background process that manages the Docker containers. Okay, so that's how you are going to think about the daemon. Okay, it's an essential tool. Without it, nothing works. Okay, it does heavy lifting of building, running. So it pretty much does everything. It builds, it runs, and it distributes the containers. Okay, I don't see the Docker daemon. If you're using a Mac and can find it, okay, so Taylor is telling you how to solve that problem if you don't see it. Um, if you're using a MacBook. Okay, cool. So what is the Docker daemon? Okay, so the Docker daemon is an essential background background process that makes it possible to um, build, run, and distribute to build, run, and distribute containers. The Docker daemon is an essential background process that makes it possible to build, run, and distribute containers. Another thing, guys, when you're answering these questions, if for whatever reason you messed up, you misspelled something, but you had already clicked done, you can go back and edit. So let me show you guys what I'm talking about. So I go to this comment, I clicked, done. It's not going to allow me to edit the answer, right? Unless you have the pro version of it, right? Um, Interesting. So make sure that you are typing everything as you wish, without any misspellings, because you won't be able to go back and edit that comment. Okay. So it looks like it looks good. Okay. So step two, you guys need to take your time when you're going through these. Okay. Look, we're just over in step two, and I've been recording for like an hour now. So it might even take me longer, okay, than I expected, but it's okay. So anyway, so let's keep going. Run a pre-built container image. So now that we've installed Docker, let's use it to create a new container from an existing container image. Okay, so we're going to use a template. We are not building our own application yet, so think of this step as your training ground for learning how container images work before you build your own. Okay, perfect. What's a container image? Is a blueprint or template for containers. It gives Docker instructions of what to include in a container, such as application code, libraries, dependencies, and necessary files. You can make multiple identical containers from the same image, and all of those containers will behave the same way regardless of where it's deployed, as long as there is a container platform like Docker, right, to run the container. This is a great this is great for developers working in a team because it means everyone gets the same experience with an application that they are all running on their individual computers. We're less likely to see situations where an application only works for some members in the team and not for others. It's also a lot faster for new team members to get up to speed with running the applications they need for their project to work. Great. Okay. So here it's making reference, just for you to be aware that this is going to work across all different systems if you're using Docker as the, container technology, right? But there are also other tools that we can look this up, right? Um, we're learning, guys. So what other tools are similar to Docker? I can spell Docker. Mm, Okay, you have Podman. I've heard of Podman. There's LX Linux containers. Right? I've heard of C Creo. Um, all right. And then there are other orchestration tools like Kubernetes, right? So there is Docker Swarm. There's Nomad. I've heard of OpenShift. Cool. Rancher. Great. So we're learning, guys. We're learning. Okay. So let's keep going. Now, in this step, you're going to spin up a container from your local terminal, see the container load a web page in your browser. Cool. So what are we here to do in this step? Okay, so in this step, I will be spinning up a new Docker container because it will be eventually used. And this awareness container using an image because because this step I will be spinning up a new Docker container using an image because it will save us time to start creating. It will save us time instead of creating the application, the container from scratch. In this step, I will be spinning up a new Docker container using an image because it will save us time instead of creating a container from scratch. Okay, cool. Back to your terminal, run the following command. Okay, so we are going to run this command. So let's go back to Docker and unable to find image locally, pulling from library engines. All right, so what can we do here now? Let's see if what does it say? Do you want to allow public? Yes, we'll hit yes. Okay, yes, I do allow. Okay, so it looks like it just installed that image. Another thing that you guys can do that I recommend doing, okay, go over, once you enter the command, of course, study what the command does, right? Go step by step. What does run does? What is dash p? What is dash pd? What is 8080? It looks like those are some ports. What is nginx? I know that that's like a server, okay? And so that's what we're doing. We're just pretty much downloading an image from a server. Okay. So that looks good. So let's keep going. All right, so we run it, and what I like, this is great. I love this. Again, I want to give a shout out to Next Work. I think this is amazing because they go into detail as far as like what each step means. For example, right, tells you here what these commands do. This is great. Okay, so it says Docker run starts a new container. Okay, so we just started a new container. Okay, what else have we done? We are using a pre-existing container called Nginx. Okay, and we are starting this container in detached mode, so it runs in the background. Okay, so it looks like we created a pre-existing we created a new container using a template, right? That's called Nginx, and we have it in detached mode, which it means it's just running in the background. Okay, and this dash p8080 says it maps port 80 on your host machine to port 80 in the container. Okay, which means you'll be able to access the web page that Nginx is running through your computer's web browser. Okay, so what can we learn from this, right? We understand that so we're basically deploying, not deploying, yeah, we're deploying the application. So we're making that back end connection, right, between the actual container, right, which is like virtualized um, with your actual computer so that you can run the application from that container uh, through those ports, and eventually it will show up on a website, and we'll probably see that, I'm assuming. So okay, so let's see. So what is Nginx? Okay, so it is a web server. Okay, exactly what I said, which means it's a program that serves web pages to people on the internet. Engineers use Nginx because it can handle lots of web traffic smoothly and efficiently. Sometimes you might hear Nginx refer as a proxy server, which means it can also be used to forward requests from the internet to other servers, helping balance the load or handle more users. Okay, sounds good. So what is Nginx? Nginx is a web server that's available online to deploy um, uh, web applications. What else does it say? Uh, Engineers use because it handles lots of traffic, a proxy server. Okay, so it's just pretty much a web server that's available online to deploy web applications. It can also it can also be referred to as a uh, proxy server because it can also forward requests from the internet to other, because it can also, I don't want to copy the same things, right? So we can say because it can also load balance traffic. Um, okay, there's another question. A container image is a container image is a what is a container image, guys? What is a container image? A container image. Blueprint or template? Okay, we'll call it template. Template for containers. Okay. I want to keep scrolling, so we're just going to rephrase this. Um, and use our own words, right? So I was going to say it's a template, right? It's a template for containers. Um, it gives Docker instructions on what to include in a container. Okay, all right. So it's a template for containers that have all the necessary tools such as code, libraries, and dependencies for a container image templates for containers that have a container image is a template for containers that have all the necessary tools such as code files, right? It has code files, libraries, and dependencies for dependencies. Yeah, I think that's good. What was the command you run to start a new container? Okay, so the command I ran to start a new container was, what command was it, guys? It was this one right here, right? So we're going to just copy and paste. Okay, cool. So we'll hit done. Extra for experts. If you are wondering where the Nginx image is from, you can find it on Docker Hub. Okay, I don't think that's really relevant. What is Docker Hub? It's a container registry, which means it's an online library where people can share and find Docker images. So I was wrong. It's not like GitHub, because GitHub again, it allows you to track changes that are made in the code. But instead here, what Docker Hub does, it just stores Docker images. Okay. AWS also has its own container registry called Amazon ECR. Interesting. Interesting. Okay. Cool. Another thing, guys, I would also recommend that you kind of start taking notes, even though it's not important that you take notes now. You can go take notes after everything. Well, actually, it doesn't really matter, but just for the sake of time here, I'm not gonna take any notes. We're just gonna continue, okay? We are 23 minutes into the video, so let's just keep going here. Open your web browser and navigate to localhost. Okay, so let's do that here. Localhost. If you see this page, the Nginx web server is successfully installed and working. Further configuration is required. Cool. So it looks like we have successfully run our first container. Okay. And again, so if you haven't really understood what we have done so far, is we've downloaded the Docker desktop, right? And on this Docker desktop, we've connected it with our computer terminal. We have deployed a container that has a contain like a we have we have used a template, right, that already exists, that have some basic um, code files, dependencies, and libraries to start developing our applications, right? Our applications. So what we have done so far is we have used this command to, you know, run Docker, right? We've make it so that it's running in the background, and we've opened up these ports for the web server to run. And what is in this web server is this, very simple website. Okay, I hope that makes sense, guys. I really hope that makes sense. So let's keep going. Okay, so we do see the website. Whoa, how did I end up seeing this? Typing localhost in your browser means you want to connect to the server software running on your own local machine, right? So what is the local host? The local host is just it's like the server on your own computer. It's a server on your own computer. So whenever you're making this connection, and it's gonna set it here, right? Since you mapped port 80 on your machine to port 80 on the in the container that's running, this happened because you run okay. The server software that local host is connected to is the Nginx server inside the container. Okay. The server software that local host is connected to is the Nginx server inside the container. Okay. Okay. Cool. That's why you see the default Nginx web page. How does localhost know to use port 80? Web browsers automatically assume you are referring to port 80 when you don't specify a port number. So when you type localhost into your browser, it's essentially the same as typing localhost 80. Now, notice how we could run Nginx server and open up a website in seconds when we're using containers. Doing this with a virtual machine like EC2 would take much longer. Creating the EC2 instance means we need to install a full operating system and other software to create the web server. In general, containers lets you load and deploy applications much faster than using virtual machines. Okay, so this makes sense to me now because I worked on the other two projects that I mentioned earlier. And basically what we had to do is we deployed an application on a virtual machine from Amazon, from AWS, which was the EC2 virtual machine, but we had to use two separate tools to make that happen. We had to use one Visual Studio to where we have our code, and also GitHub, right, to store that code in the cloud so that other people can access it. But here instead, everything is much simpler because we just had to run one single command to be able to one run the application, all right, and then also to make it so that anybody can access it. So this is great. So we're gonna take a screenshot of what that looks like, right? It wants us to take a screenshot of the welcome page, so we're going to do that. So and we'll do and Jinx. Okay, so I think we're making progress. I think what we're doing so far makes sense. If you guys have any questions or anything, do you have different resources, right? You can use these to, if you get, in case you get stuck, you can go here. Otherwise, just ask me in the comments and I'll see if I can answer your question or at least point you in the right direction. Start your answer. When I visited localhost, I saw the website loaded on my favorite web browser. Yeah. Okay, so step 3, all right? Let's go ahead and do that. Build your custom image. Now that you understand the basics of Docker, let's build our very own container image. Okay. So in this step, you're going to write a set of instructions that tell Docker how to build your custom image, container image. Get Docker to read your instructions and build the image. Okay. What are we here to do in this step? In this step, I will be creating a container image from scratch. How do you spell scratch, guys? Because we want to because we want to customize it to how we want it to look like. In this step, I will be creating a container image from scratch because we want to customize it to our liking. In your local computer desktop, create a folder and name it compute. Challenge yourself to do this. Okay, so skills, guys. You're going to use your local command prompt, okay, and it's really easy. All right, so we're going to create. So we're going to go to our desktop, and our desktop we're going to create a new folder called what? Compute. And we're going to go to that folder. Okay, so that looks good. Create a new file called Docker file. Note that there is no file extension after the file name. Try to challenge yourself to do this, your terminal. Okay, so you can use that touch. So now that we are in this specific path, we're going to just create that file, right? So we're going to call it what? Docker file. And actually touch might not, I don't think it's going to work on Windows. It might be a different command to create the file, but again, Docker file, right? It's Docker file. Okay, so there is, how would you create a file on a Windows? I'm not sure how to do that. So we're learning, guys. We are learning. So where is my ChatGTP? How to create a file using command prompt. Maybe it's going to say make echo. Okay, so again, so let's see if we can just do echo Docker file. Okay, so we just created that. All right. So add the following lines to your Docker file. Okay, so now we have to access that file. Okay, so how do you do that? Don't know. I don't know. Maybe that's when you do touch. I'm not sure. Type. Okay, so if we do type Docker file, the system cannot find the file specified. Okay, so looks like we're going to get stuck here for a little bit because we need to find the correct tool to open a text file. If this is a text file, I'm not sure. So, a matter of fact, we can just check that if we go to our desktop and we go to compute, there's nothing. Okay, so let's see what is going on. A Docker file is a document with all the instructions for building your Docker image. Docker will read a Docker file to understand how to set up your application environment. Let's see if we can head to that directory here. So we're going to do, can you send, oh, you cannot type here. Okay, so can we do this echo? I'm not sure what's going on. There's like a lag or something here. Why can't I see the whole thing? Echo doc, actually cd desktop cd, what was it called, guys? I forget. Compute, and we're going to do echo docker file, and we're going to do, what was it, file type, type docker file. It does not exist. So to my understanding, we need to give an extension because we need to, say what type of file this is. But here it said create a new file in your compute folder called Docker file. Note that there is no file extension after the file name. Try it and challenge yourself to doing this in your terminal using commands. It looks like it's not creating anything. Even if I do it within the Docker environment, I'm not sure. Not sure. This looks like a text file to me. Okay, so it looks like we don't have much information. Okay, guys, I'm going to just stop here and we are going to continue once I take my little break. So I'll see if I can do some research before, but we'll see. I'll see you guys in a little bit.